22 seconds.
Oh yeah, our mic's on live. Hello everybody. We're about to get started.
Oh yeah, okay. I'm mic'd up.
All right, well, thank you for joining us. I did not put AI in my title, so we are at the end of the show. But thank you for all those who have stayed put. Today we're going to talk about how to run a successful Azure data analytics project. We're going to cover a few things. We're going to start around some common data analytics challenges that you might face if you're going through this. We're going to cover best practices for two common patterns, medallion architecture and data lakehouse deployments, and then also real-time intelligence deployments as well. And then we'll talk a little bit at the end about how you can get help from Microsoft via our offerings like Azure Innovate, Azure Migrate, and Modernize. My name is 𝗦𝗲𝗀𝗀𝗶𝗁. I am Director of Analytics and AI Strategy in Global Customer Success, and I've had a long career in IT and technology doing software development and data analytics migrations, and now I have the pleasure of leading a team that does analytics migrations for our customers. Turn it over to you, gentlemen, to introduce yourselves as well.
Hey everybody, great to be here. I think you can hear me. I'm glad that you can hear me. First time in Chicago. I've had a great time. This is a great city. Anyways, my name is Andres Padilla. I'm a data and AI engineer. And when people say, what do? I'm the angel on people's shoulders, telling them if it smells right, if it looks right, and what they should do, and how to apply all these great concepts into their babies. And those babies are your analytical workloads. So that's what I do on a day-to-day basis. Good to be here.
Good afternoon, everyone. My name is Hiram, same team as Steven. I lead the real-time intelligence migrations for our team, and it's a pleasure to be here and speak with you guys more today.
Awesome, thank you. So we have a lot of challenges, right, in today's analytics environment. We have a complex data estate that has issues with data sprawl, data silos, data duplication, poor data quality, infrastructure inefficiencies, high costs, limited interoperability, and data exposure risks. These are not ideal places to start your AI innovation. And for businesses looking to streamline and advance their data estate, the burden is often on you, the data leader, to evaluate potentially thousands of data and AI offerings, find the right set of services, figure out how to integrate them, and do it in such a way that is scalable and flexible enough to evolve over time. And so these are some of the challenges that we have on the screen here that we see often. Any others, Andres, Hiram, that you guys see that you want to touch on as well?
From my experience with all the customers that I go through, I think what holds them back is that they don't have a good reference of how to interconnect all the dots. And they ask me, at what point do I start to include governance? At what point do I include security? My job today, if it's anything that I give you, is I give you lineage that you should, at this point in your process, be applying a little bit of security, be doing data quality checks. That lineage, or giving you that stepping stone approach, now starts to clear up those concepts for you.
Yeah, absolutely. So in most cases, data is this part, so it's coming from varying sources. A lot of customers want to somewhat migrate the data and leverage the way that they've always done it, but they come to us to sort of identify what other offerings or computer technology is available to leverage the right destinations as far as when you're migrating the data. If you think about that project, move it in sections, as opposed to tackling something that takes longer to accomplish.
Yeah. So it's great. Yeah, bite-sized pieces is some of the things we'll talk about as well. So this is the starting line, right? Most organizations have data environments that have grown organically over time, right, with specialized, fragmented solutions. It's a complex data estate that leads to sprawl and duplication and some of the other things we talked about a little bit earlier. And a lot of chief data officers are asking, how do I simplify this? And if you look at this diagram here, you have enterprise data sources. It can be your databases on premises. It could be cloud data sources. It could be some foray into the cloud analytics space. And there are multiple teams, many times, trying to make sense of that data for their business units or business users that are looking for those insights. And it takes a lot to bring it all together and then, hey, I don't have access to this data, I need to pull it in, and now I've created a silo on my own. So that's kind of where we're starting at. And this is what we're trying to get to, right? It's this place where all of my data sources that have been built over time can be put into this unified data foundation. And that unified data foundation can be the place where all of the various teams, business units, and groups, personas in the enterprise can access that data, have access to the right data for them based on their roles, and then we can obviously leverage AI on top of it. So this is kind of the finish line that we're going to, and some of these icons are things that might be familiar to you in your data estate that you guys have to deal with on a daily basis. So how do we get there, right? With the launch of Microsoft Fabric, we've embraced an open and governed lakehouse as the underlying SaaS storage layer for Azure Databricks and for Fabric. This means our Databricks customers can seamlessly integrate with Fabric and augment their analytics systems with generative AI on top of the same open and governed lakehouse, right? As a first-party offering, Azure Databricks customers will be able to take advantage of a variety of Azure capabilities and augment their analytics systems on top of the same open and governed lakehouse. So the structure underneath what we do with Fabric, what we do with Databricks, is this concept of delta parquet, of a lakehouse that your compute layers can operate over. So Fabric also natively integrates with Purview. We talked about governance and lineage before. Purview, Microsoft Purview, some of you may have known Azure Purview before. We've now changed that product to be much more full-featured across the Microsoft stack. Microsoft Purview is what you can use to help with information protection, data loss prevention, and auditing. And then on the Databricks side, many of you may also be familiar with Unity Catalog and that integration there. So lots of different ways that you can do this in Azure, but both platforms, the key is to have that open and governed lakehouse foundation. Go ahead, Andres. Let you take this slide.
So we're going to start getting into some of these best practices. And the way we would like to break it up is, if you look at this graph, there's going to be a readiness section, a governance section, and we're always going to measure and monitor and rinse and repeat. Today we're going to talk a little bit more about the medallion architecture and what kind of best practices you're going to throw at that type of environment. We're also going to inject a little bit of real time into it. But what I want you to know is that at that readiness stage, when you land on that readiness rock that you're going to jump from one to the other, you're going to start building out a strategy. What strategy are you going to implement that's going to tell the best story? At the end of the day, your job with these analytical workloads is you're a storyteller and you're trying to extract a story from your data. You're going to start to train up. That's another little item that you're going to have to start to get acclimated with. What tool sets you have within Azure? How do I govern this? How do I secure this? Now we start getting and bleeding into that design and governance section. And in that design and governance section, you're going to start to get familiar with what can I do to tell me who has their hands in my data? Where did that data come from? And then we're going to start to optimize the whole process. If there's a golden rule that I try to tell my customers is get the water flowing from beginning to end as soon as possible. Throwing everything into a mix and trying to see it all completed with every single file format, real-time scenarios, it's going to take a long time. The sooner you get the water flowing, the better you start, the sooner you can start applying these rinse and repeat sections into it. And there's one more section that I want you to, one more thing I want to remind you guys. All these areas, all these three categories, you're going to throw those 5 well-architected principles at it. They have to be secure, they have to be performant, it has to be operationally excellent, it has to be reliable. And what was the fourth one? Did I mention all of them?
Optimize.
Optimize, thank you. Security will go hand in hand in every single stage. I want to know who has access to it, apply role-based access control to it, what kind of granular control can I have over the data. You'll start at every single one of these stages in your architecture, in each one of the layers, you'll apply these 5 principles. If you haven't visited the well-architected framework within Microsoft Docs, please get that into your system. It will help guide you of how to implement a well-landed analytical workload in your environments.
Awesome. So across these two architectural patterns, we're going to discuss some of those concepts. Like I said, we'll start with medallion architecture. We touched on that a little bit. Hiram will also talk about real-time, which is a new architectural pattern that we are seeing more and more common. Customers have been asking for real-time for a long time, and we usually are near real-time. And most people would say real-time is 5 minutes, right? Because that's as good as we could have done for a very long time. Now we're getting into the seconds and millisecond latency between data being created and data being visualized. And so we'll talk a little bit about that because that's an important pattern we're seeing. So let's get into the medallion architecture best practices. And I'm going to just ground us in an architecture diagram. And these four are the four common stages that we end up going through when we are moving data or bringing data into an analytics environment. The first is our ingest stage. That's where we look at our data sources, whether they're on-premise cloud, flat file, database, whatever they happen to be. We're evaluating those initial sources to ingest them into our first layer. And the goal really is to get them into this transformation layer where it's really the same as the original source, what we call the bronze or a raw layer, and we'll talk about some best practices for the bronze layer as well. We started the journey of analytics years ago with ETL, extract, transform, and then load, and we've slowly shifted to being extract, load, and then transform. And this pattern really demonstrates that. You're loading the data, and then the transformation is going to come later. And that transformation happens over 2 more layers. The silver layer is a more curated zone of data where you're combining multiple sources together to make sense out of that data. And then finally, you have this gold layer, which is a highly curated data source, which you're building your visualization on top of. And this is a sample architecture. You see in one section we're using Databricks, in another section we're using Fabric. You really can transfer some of these concepts to both technologies. You can have a pattern that's fully Fabric or a pattern that's fully Databricks. But we like to show that you can have that interoperability between the two services. And then key on this diagram as well is that storage layer, right? The key storage layer in Azure is Azure Data Lake Storage. And so that's where you can land all your data. And now we have this amazing concept of one lake, which is this one drive for your data. If you've been here this week, I'm sure you've heard that term before. So that's the architecture that I want to ground us on. As we look at the ingest part, this first part of the medallion best practices, right? We talked about some of the key challenges that businesses are facing on building that data foundation, right? By adopting and applying a lake-centric medallion architecture, you can help alleviate many of those challenges. First, we want to apply architecture principles by ingesting raw data into our bronze layer. This is where we're going to store that raw data in its native format and preserve the original fidelity and enable reprocessing if needed. Next, we want to capture the lineage during the ingestion process. Andres talked earlier about how do we capture that lineage, what are some of the tools and why that's important. During that ingestion process, we want to capture and store the metadata about the source that it's coming from, including source system details, extraction timestamps, any other transformations that we applied during that initial ingestion. And this helps tracing the origin of the data and understanding its initial state and capturing the data lineage with either Unique Catalog, which I mentioned before, or with Microsoft Purview. And that's ensuring that traceability in the transformations. And this also helps us enhance the compliance of our data and support data quality for providing a clear audit trail from raw data to redefined data sets. So those are some of the things, you can scroll for me as well. Those are some of the things that we want to think about. And I think compliance is a big one that I'm sure a lot of you all are dealing with as well, especially with many of the laws coming in place around data and being able to trace data for users. So having that traceability is super important. And then applying data quality checks is that next step in this ingest layer. We want to ensure that the data quality at the source is good. I'm sure all of you have heard garbage in, garbage out. We've been hearing that for years, right? And that's super important. If it's crappy at the beginning, it's very hard to fix it at the end. And so this is something you want to do in that when you're taking that original data, making sure that it has good quality at the beginning. And then lastly is this concept of metadata-driven ingestion pipelines. This is something my team has been working on for the last couple years, where they're using the metadata of the source to be able to automate that ingestion process. Rather than having to go and build all of the ingestion pipelines manually, you can leverage the metadata to help understand what data is coming in and automate some of that process. And that's been a new pattern that has really arisen over time. Next, we get to this transformation layer, right? We're refining it. We talked about the bronze layer. Now we're going into the silver layer. So we are refining the data and enriching the data in silver layer. We're combining different data, or we're maybe adding some information about that data. And we're doing some data cleansing. We're applying business logic to the data. And we're creating those refined data sets. We're still going to continue to capture that lineage over time. We want to track what transformations occurred from the original raw source and into the silver layer, including what logic and code we use to do that. And we can use tools like Delta Lake's transaction log to automatically capture those changes if you're using Databricks, for instance. We'll automate deployment pipelines with CI/CD. It's become very important to track what changes we're making to the deployment pipelines. Not just, hey, we're making changes, but we're making changes to how the deployment pipelines run, so when we have issues in data ingestion, we can go back and test those. So using tools like Azure DevOps, or many folks are using GitHub to build, test, and the deployment process is critical. And then lastly, partitioning your data in ways that are meaningful to your users, and for the best query patterns and characteristics of those data as well. So that we have gone through ingestion. Now we've done some initial transformation of that data. Now we want to serve that data, right? We want to make use out of it and make sure that it delivers business insights. And that's where the gold layer comes in, right? This is a subset of your data that's been highly curated and that is ready for users to visualize or gain insights, and we want to model that in the gold layer and bring the business logic to it. And we continue with that view of that data lineage that carries through in every single one of these layers that we're going through. Access control is important. Fabric has very fine-grained access control. ADLS has very fine-grained access control as well, getting down to what we call role-based access control to the individual user who has access to individual parts of that data. And so we want to leverage that no matter what solution we're having, that a user at the end that's looking at that report can't see data that they're not supposed to have access to, and that user information flows throughout all layers of this process. And then we're also going to create robust data modeling that support reporting and analytics needs, and we can use things like star schema, snowflake schemas as well to help with that data. And then lastly, it's where everybody sees the work that's been done, all of this work that's gone on under the covers to make this a reality, and it ends up in some kind of visualization, right? We talked about development, CI/CD earlier. You can do that with your visual reports as well. It's not just for your data transformations. It's also for your report files to make sure that changes to your reports have a history of what's been changed over time. We've also built design principles for reports to help with things like accessibility and actionability, which is probably a word we made up, is my guess. But there are, raise your hand if you've seen a really ugly Power BI report. I know I have, even at Microsoft. And raise your hand if you've seen a Power BI report that you didn't really realize was a Power BI report. And so we've tried to codify a lot of those design principles, and we've actually put them online into something we called Semantic Labs that helps you actually test your reports against best practices. You know, is the contrast too high? Are buttons too small? Are these tables not really useful? So we've done that to help you, and it actually has a lot of other features in there as well. So Semantic Labs is something that I would look for. We have that on GitHub to help you test your reports as well. And also allows you to decouple your reports from your semantic model, right? And that's one of the new concepts is, hey, you have your model of your data, and then you have your report. The more you can decouple them, the better. And then lastly, even though I didn't put AI in the title, AI will show up in every deck at Ignite. So Power BI Copilot and Copilot across Fabric is something that is now available in many cases. And it's amazing to see what you can do in helping adjust reports and gain insights from the data through conversation rather than having to drag and drop or understand the data just from visuals. And you should anticipate over time that conversation is going to be the main interface in how you interact with the data. And so that data foundation is really important. So as we get to manage and optimize, let me turn it over to Andres to cover this topic.
I love this slide because now we get to a point where I hear from customers, I want to make this go fast. In the great words of 𝗦𝗽𝗲𝗍𝗶𝗵𝗁, I want to go fast, fast, fast. We got to get more cowbell. Let's unpack these. What I want to talk about is let's lean into that operationalize and automate. You can wrap CI/CD around your data flows. All this stuff can be DevOps. Can throw this into GitHubs. There's great samples out there in GitHub or for DevOps pipelines of how to rinse and repeat and get this flowing in an automated fashion. For logging and tracking, what I want you to know there is that there's great tool sets in Azure that will tell you the story of who has access to what files, how much money are you generating, when did someone come into a particular folder. For Databricks, if you guys are leveraging Databricks, look at Ganglia or look at Grafana. The dashboards that come in Grafana for Databricks are right out of the box, and they're beautiful, ready to be used. You can write KQL statements if you really want to get really granular and start tracking costs, performance issues. When it comes to Zero Trust, same RBAC. RBAC, we can tell when someone is trying to access a file, where they came from, when did they try to do it. And the biggest question I get from customers is, hey, I want to make this go fast. So what I want you to know is that this is an incremental process of getting more juice more juice for the squeeze. You want to start thinking about partitioning. What can I do to partition and organize the data, because you want to avoid those hot partitions. You don't want all the data to consolidate into one big area, because then I have to read all through those files. You have to think about, there's a number of lists, and there's great documentation in Microsoft Docs of how to get more speed, not only from your clusters, but what things you should be thinking about from what files should I thinking about. For real time, should I look at Avro files, or is Parquet best for me? What else can I tell you? Leveraging caching. Caching is big in Databricks and materialized views. Can I leverage caching? What can I do to not have to go back to the file system and read that out? There's plenty of little tricks in your Swiss Army knife that you can pull out. Partitioning is the first one you should be thinking about, and organizing the data. The next one is file choice. What else can I do? Now we start getting into the clusters. This is an incremental process that is a little bit, in my opinion, more art than science, where you have to throw the workload at the cluster or your compute choice and see, hey, is this actually, if I'm pushing the limits on this, or is this bogging myself down? And then you have to go back to your log analytics or your logs in order to get some information out of it. Okay, yeah, there's some holdups there. It's consuming a lot of memory. Let's talk a little bit going to costs. What can we do there from your storage formats? Leverage lifecycle management. We have some great tools in your storage to make sure that, hey, if the data is used consistently, make sure it's on a hot tier. If it's not, I can start moving over that data to a cool or an archive tier in order to save $1. We want you to save money on these things. So we're giving you the options in Azure and in Databricks in order to make sure that you're not over-provisioning clusters, or can I do more to save costs on the storage side? A couple more things that I want to mention here. Security and access control, think Purview, think Unity Catalog. Unity Catalog and Purview are going to tell you when did the data come in, who has their hands inside that data, at what point does someone else have access to that data. That lineage, sooner or later, your companies or yourself are going to get audited, and they're going to ask you that question. Who has access to that data? At what point do they leave access from that data? Those tool sets, Purview and Unity Catalog, will tell that story beautifully and easily for you. A couple more things before I pass this over to Hiram. Yes, scalability and flexibility in both Fabric and both Synapse and in Databricks. You can scale out your workloads. So, hey, can it consume one concurrent cluster? Sure, that's heavily used and I can scale it out based on usage, we give you those options. We give you the options also to save on costs when it comes to workload choice. You can pay in advance, say, hey, hey Microsoft, I want to pay 1 year in advance and save $1. So there's a number of strategies that you have in your back pocket in order to manage it and optimize it, make it go faster, and save $1 if you wanted to.
And I think a couple things on the scalability side as well. As we look at both Databricks and Fabric, they've continued to move towards a more SaaS model of how they provision resources. And so, for instance, Databricks has moved to what they call Databricks serverless, where rather than you managing your underlying infrastructure, and rather than you managing your compute, how many VMs you have, when you spin it up, you basically are submitting your queries to the Databricks service, right? And Microsoft determines how to bring the right compute resources to run that workload, and you're paying for the compute at that time. And Fabric has a slightly different model where you purchase compute at a SKU level, but then you're bringing all of your various workloads onto the same compute. So if you think about how you would traditionally do it, you would pay your Power BI licenses here, then you'd pay for your data ingestion workload here, then you'd pay for your data warehousing here. All of that were separate costs that you would have to manage as a business. And now with Fabric, you have one SKU, and all of your workloads are consuming from that same capacity. So you can really heavily optimize your workload by bringing multiple things onto the same capacity and leveraging them at the same time. So both have slightly different patterns in the way they've done this, but the end goal is that optimized approach, that scalable approach for your analytics solutions. So let's move on to real-time intelligence, and I'll hand it over to Hiram here to talk through some of those best practices. Go ahead.
Thank you. Did anyone get a chance to try the 𝗲𝗫 game down at the Microsoft Hub yesterday or earlier this week?
One person?
No?
Only one person went and drove the race car? Oh man, that was the best booth. You guys missed out.
So some context on one of the booths that we had, there was a racing car that was set up, and it was connected to an Xbox. The Xbox had a sensor on it, and it was streaming the data of the game in real time to Microsoft Fabric, logging all of the GPS coordinates of the car, the RPM of the engine, the temperature of the tire, everything that the game would actually produce as if you were a real race car driver, and storing it in Fabric and visualizing a dashboard that was keeping the metrics of all of the participants that were trying out the game, as well as who was the fastest performer. But doing this in real time at scale is quite challenging. One of the key features that's very up and coming, well, I'd say a lot of customers are showing interest in, is the real-time intelligence features inside of Fabric. But prior to Fabric, we would implement similar architectures using our past offerings such as Azure Data Explorer, Event Hubs. And we've taken these technologies and coupled them inside of Microsoft Fabric, where it's a single click and all within your workspace. You don't have to network it or secure it outside of, as you would in Azure. And it's very attractive. It lowers the TCO of the customer, pardon me, so that they get a higher ROI, and the developers are able to start landing data, ingesting it, and deriving insights sooner, as opposed to waiting for infrastructure to be spun up, secure, like we used to do in the past world. However, there are high volume implementations where it's still applicable to leverage these battle-proven architectures by leveraging the past services. And Microsoft Fabric might be relatively new, but all the features for real-time intelligence have gone GA. We announced that earlier this week. So I wanted to bring actually one of our customers that we migrated earlier this year, Mozilla Valley Transportation. They're a transportation company, as you can imagine, and they had a unique challenge. They were running telematics of all of their fleet and storing that in Azure SQL DB. Not that there's anything wrong with that, but when the data starts to grow over years of doing this business, it truly starts to become high volume. The number of trucks increased, and they were evaluating Microsoft Fabric to migrate this workload. And when they came to us, they were like, okay, Hiram, we have these set of tables that we have to move, but there's one table where multiple sensors of the vessel, of the trucks, as well as the GPS coordinates that the driver is holding, are landing inside of this massive table. And our priority for this migration is to move this table into Fabric so that we can start doing analytics. So the customer had attended some of the RTI talks, the real-time intelligence talks, where they saw other customers such as Taco Bell, McLaren using this technology, and they were very excited when we spoke with them that it was a good fit because telematics is typically telemetry or IoT sensors, meaning the data is time-bound. When you're doing analytics over this data, you're kind of querying your data with specific metrics over time. So for the last 2 hours ago, where was the truck located? Within the last 5 minutes, what is the temperature of the room? I lost my cell phone. Can I do the Find My Phone app and it pings the phone current GPS location? What is the current battery level of these devices? Things around that nature, but having to do this over time, the data, when it's time-bound, we're able to seek where the record for that time window is exactly located. So everything inside of the service is indexed for you. The RTI features allows us to bring data streaming. So the customer was using Service Bus with Azure Functions, so we'll get into the architecture. But the benefit of the program is that within a matter of 6 to 8 weeks, we completed migration that accelerated their adoption of Fabric that would have taken months or years. So it's a great benefit that all of our customers can leverage, and we're here to help in case you're interested in migrating as well. And there's direct feedback on the screen from their director of product development. It was a pleasure working with them. So we're looking for more opportunities to see other real-world operation workloads. In this case, this is an example architecture that we run into a lot, specifically around transportation, logistics. In this case, a customer may be sending data from their trucks via Azure Functions from the dispersed telemetry provider. Landing that data inside of Service Bus to queue through the signals and decide whether, okay, is it an arrival, a departure? Do I need to send a notification? Has the ETA been affected? Because there's SLAs on how, at a given time window, that the truck has to arrive in case that they're delivering food, medicine, or other goods. And traditionally, the data will be processed by another Azure function and landed into Azure SQL DB. So we connected, at the time we actually shipped earlier this week, a connector natively inside of Microsoft Fabric that reads directly from Service Bus. But we connected prior to that feature being available by going through Logic Apps. Logic App has over 400 connectors. It's very similar to Power Automate. And we read the data in real time from Service Bus and sent it to Event Stream. Now, I talked about Event Stream is actually a mix of Event Hubs and Azure Stream Analytics, where it gives you the same endpoint for an Event Hub if you want to connect to it via Kafka or SDKs such as C#, and process that stream by transforming it, meaning I want to filter signals that are coming from one telemetry provider and land it in the lakehouse, or land it in a specific table, or land it inside of the event house for real-time analytics. So the historical data that was sitting inside of Azure SQL DB, we moved the historical data via pipelines, which is very effective. The best practice there, even though the system can sustain up to 4 gigabytes in payloads, the best practice is to ingest that in buckets of 1 gigabyte. So we bring that into the event house, and we again follow the best practices as Steven and Andres covered by building a medallion architecture, landing the data raw, whether from the hot path that's coming from the event stream as bronze, transforming that to create the silver table. We do that transformation using an update policy. Think of that kind of like as a SQL trigger, where you define a function, and the function gets triggered as the stream is flowing through the ingestion pipeline. It creates a silver layer and makes the data available in one lake availability, where customers may want to take this telematics data and now join it to other ERP data within their data warehousing, create whether possibly materialized views inside of the event house, or join it to enrich that data with other information that's available inside of their lakehouse per se, or data warehouse, inside of their Fabric capacity, ultimately building Power BI reports. And we get into scenarios or real-time dashboards where which visualization tool should I use for these use cases? And we'll talk about that more in the next slide. But one of the key things about the architecture here is you're seeing the last pillar that you can act on your data. And this is without having to author the act or creating the logic app by going through more programmatic step, the real-time action of Data Activator is a user-friendly experience, so you can click next, set a certain threshold, and create a notification, whether it be a Teams message and pings or an email, or more advanced actions, so more applicable to real-world scenarios, such as alert the individual store manager based on performance of inventory, or create a smart ad campaign.
And the thing I'd just point out here about this ACT pillar, right? This, obviously you didn't see that when we were talking about the medallion architecture, but certainly you do act on reports. But the goal of the ACT pillar is really for it to be in near real time alerts or to the relevant party that needs to take that action because something's going on, right? Something is wrong in some way. Like a cooler is getting too warm or an inventory is too low.
The truck is late to the warehouse.
Truck is late to the warehouse, exactly. So there are we've created real-time actions to be super flexible in how it sends those messages, and then also being able to interact with other kinds of messaging services that may exist today. But that is really the key. Like, it doesn't make sense if all of this data comes in and you still have to go and look at a dashboard and make a decision. At the end of the day, you need the system to be identifying what needs to happen and informing the right person. And there were some really cool demos in the real-time intelligence session around how we're putting generative AI on top of it to detect anomalies in the data that would be much harder for a human to do as well. So that's just something that I would look into if you're looking into real-time scenarios, something you can implement going forward. It'll be coming out soon.
And in the real-world case of the customer I just mentioned, imagine they had an SLA where they were geofencing the entire fleet, or 50,000 trucks, within a matter of 15 minutes per se. After the migration was completed, we were geofencing the entire fleet in under 4 seconds. So it really ramped up their adoption of the project.
Please don't gloss over that. They went from geofencing the entire fleet in 15 minutes to doing it in under 4 seconds, right? That's the difference in speed of processing power and ability to take actions. We have a few more minutes. We'll cover the next couple slides, and then we'll talk about how you can engage our team.
So some best practices for ingestion, applying the medallion architecture so that you can always query the data from bronze if you have to revert the transformation, leverage materialized views, capture the lineage for the data as well. We talked about data governance. It's very important to understand how the data was transformed, what kind of data this is, whether it's PII, financial sensitive. Being able to apply data quality checks. So when we're migrating the historical data, one of the key features is we want to use this creation time pattern so that the data gets indexed as of the historical date. If it's as of 2021, we want that index as of 2021 so that it doesn't crush the hot cache just because it was migrated today. It doesn't get indexed as of today. Migrate the right workflows. So if this is for real time, we typically lead by identifying that the workload is time series in nature. It is time bound in nature. So that would be a good fit, as opposed to if it's traditional fact dimensional data from ERP systems, might not be the best fit to leverage the real time architecture per se. Use the metadata ingestion. A lot of customers want to parameterize or make their ETL pipelines dynamic. There are features to do this within the ETL, the event house, where you can create update policies. I talked about the update policy being similar to a SQL trigger, and the update policy can take function or specific logic to store all of those transformation steps and trigger automatically for you, as opposed to having to author them every single time. Visualizing the data, obviously consider your audience. Either leverage the real-time dashboard for operational. Let's say you need a simple visual that shows you the exact KPI. What is the number right now with minimal latency, everything just live. That's a good example of operational dashboards for observability. Like Andres talked about Grafana. The real-time dashboards are very similar to Grafana. And leverage Power BI reports for your traditional business intelligence, such as sales, order, financial, to be able to tell that rich data story for your audience. Try to tell a story on one screen. Don't develop reports where folks have to toggle between different screens and it takes them longer to derive at the insight or navigate multiple panels, multiple pages. Accent the most important, like leverage conditional formatting when it's within a specific threshold that's simple to identify it in a color code that makes sense to your organization. And lastly, as hand it over to Steven, like leverage the intelligent actions, which is a unique differentiator inside of Fabric, whether you want to trigger that reflex item or that data activator item from the event stream or from Power BI after the data has already been curated. These are all features available inside of our technologies within Fabric or Microsoft Azure. Optimizing the data, a few best practices for data partitioning. This is when it really gets to high volume. We're talking about hundreds of petabyte scale, where you want to have a column that is very low cardinality, the right partition strategy to query this data over the table. Leverage the leader-follower architecture so that this is a way to go beyond the compute capacity of an individual cluster or for data share capacity. So now that does have to be within the same region as opposed to having to ETL the data to your customer every single time, giving them a CSV. The leader-follower architecture, they can have their own compute, they pay for their own compute, but the data is always fresh, and they can build their own reports on top of that. There are best practices for KQL queries. If you ever use, KQL stands for Coastal Query Language. If you've ever queried Entra ID, Microsoft Defender, Sentinel, Azure Monitor, Application Insights, it's the same query language there. And the top one best practice we recommend is filter always by time. And then from there, continue to develop the additional steps for your aggregations. Obviously, monitor your workload. Keep a close eye on what's going on so that your compute doesn't grow or sprawl beyond something that would be unexpected. And leverage the optimized auto-scale feature, where this is predictively scaling up or down based on the pattern of your workload. It takes us normally about 6 days to learn the pattern of your workload, and it'll auto-scale up or auto-scale down without interrupting your queries.
Awesome.
Thank you.
Thank you, Hiram. And then just something to think about that Hiram mentioned as well. Traditionally, all data has used databases for analytics, or in modern times, we were seeing a lot of lakehouse analytics solutions. A lot of data is time series data and is better served by a real-time solution. And so as you go out, don't just think, oh, analytics, I need a data warehouse, which is a common misconception people make, is like, oh, I need a data warehouse to do analytics. No, there are real-time solutions that are a better fit for many of these workloads. And so start to evaluate those time series patterns and look to leverage real-time solutions for those. In the last 2 minutes that we have here, we talked a little bit about readiness, right? Skilling is super important. Microsoft puts a lot of energy and effort into our Learn platform. Please make sure you take advantage of our training on Fabric, on real-time intelligence. We now have 2 Fabric certifications, Azure certifications. So if you want to be an analytics engineering associate, data engineering associate, these are great certifications that will help you gain that experience on the platform. If you'd like to get engaged with us, we have different offers that now customers can engage with. Azure Innovate is one for analytics migrations, for building AI-infused apps. My team runs a program called Migration Factory, and as Hiram mentioned before, we've migrated customers onto real-time solutions, onto Fabric, onto Databricks, onto Power BI through that as well. Yeah.
From P to F SKUs.
Yep, from P to F SKUs, as well as those who are doing those transitions for Power BI. Azure Migrate and Modernize will help you with some of that infrastructure and database migrations. And we also have Azure Essentials, just around getting your landing zones stood up. How do I get my Azure infrastructure in the right place for these migrations? This is kind of an overarching view of what happens through the various phases, defining a strategy, planning, readiness, adoption, governance, and manage. And then lastly, this is kind of a leave behind slide. If anybody needs a QR code or anything, if you are interested in getting that help, you can go here and you can actually nominate yourself. Before, you'd have to nominate through a Microsoft account team. Now you're able to nominate yourself if you would like access to any of these programs. And with that, thank you. Thank you for joining us for Ignite. I hope you enjoyed the show. And please let us know if you have any questions. Thank you very much.
If there's any questions, please feel free to come up. We'll be here. And there's a microphone as well so that it gets...
You're born
go ahead.
speaker.
Okay.